So this is the part B of the last example from our notes on Wednesday. It's very similar to the problem we did earlier with sine of L equals 8/17. The only difference is here we're not given a numerical ratio, we're just given the value of n. But the problem works the same way, just the algebra is a little heavier. So we'll start with sketching another right triangle here. Label it the same, LAR. And what I know is that the sine of angle L is equal to n. From our last example, we knew that the sine of an angle is equal to the y over the r, which is the opposite over the hypotenuse here. And if I look at my ratio over here, it's n over 1. So now I can kind of label the n as my opposite and the 1 as my hypotenuse. And I'm going to now kind of move over to the diagram and start labeling my diagram. So everything's with respect to angle L. The opposite is here. My hypotenuse is here. So I can now label my opposite side length as n and my hypotenuse as 1. I need to find the secant of L. That's our goal, right? So the secant of L is what we're looking for. And if you remember, secant of an angle is equal to the r radius divided by the horizontal value x, which is the same as your hypotenuse over your adjacent side. So I need the adjacent side length right here. I'm going to call it x. Right? 1 is a given value, n is a given value. So to find the value of x, I'm going to use Pythagorean's theorem here with 1, n, and x. So that'll leave me with 1 squared is equal to n squared plus x squared. We're going to solve this for x. So I'm going to subtract n squared from both sides. 1 squared is 1. So that gives us 1 minus n squared equals x squared. And then I'm going to take the square root of both sides to isolate x. Don't worry about plus or minus at this point. That's because these are triangle side lengths, which should remain positive. So x is equal to the square root of 1 minus n squared here. So this is my adjacent side length, which is square root of 1 minus n squared. Now I can take this information and start working on my secant of L calculation right now. So secant of L is going to be equal to the opposite, or excuse me, the hypotenuse, which is 1, divided by the adjacent side length, which is the square root of 1 minus n squared. And we don't like that because there's a radical in the denominator. So what we're going to do is we're going to rationalize here 1 minus n squared, 1 minus n squared. And this will leave us with secant of L equals square root of 1 minus n squared over, and then root 1 minus n squared times root 1 minus n squared gives us 1 minus n squared here. That's as far as we can really take this, and that's what the secant of L is going to be equal to. A lot of algebra. So I would target this level of rigor for this type of question.